All right, everybody. In today's lesson, I want to look at cash flows. So this is going to be focusing on cash flows for any profit, for-profit or not-for-profit enterprise, any kind of government entity, any kind of corporation, things of this nature. Okay, so why do we look at cash flows? There's a few reasons, and there's a few focuses too. Okay, so we have operating cash flows. This represents the cash used in the core business operations. Okay, so anything that helps the company with its day-to-day activities. Okay, we have investing cash flows. This reflects cash flows used to generate investing activities, purchasing or selling assets, different parts of the business, different investments that the business makes, mergers and acquisitions, things like this, right? We have financing cash flows. This represents cash flows related to financing of the business, such as issuing stock, borrowing money, repaying debt, things like this, right? And there's other cash flows too. If it doesn't fall into one of these three primary buckets, there could be miscellaneous types of cash flows that the enterprise will utilize for its different engagements in different parts of its business, right? And there's two types of people, or two groups of people that focus on cash flows. Sometimes it's accountants. They focus more on the accuracy of the data. Basically, for financial reporting purposes, there's GAAP, generally accepting accounting principles in the United States, and IFRS outside the United States. And accountants basically produce financial statements, right? So we'll see in just a moment here, operating cash flows, investing cash flows, and financing cash flows. Finance professionals, on the other hand, will use cash flow analysis to support decision-making of the business, right? The long-term continuity of the business, strategic planning, financial forecasting, and they'll use cash flows to understand the company's financial health and overall stability, right? Okay, so I put together some Python code as usual here. Let me click Control-Enter to run the cell. And you'll see here we're going to this link. If I copy and paste it over here, we will see a slightly different view, same data. We'll see what we're looking at. Okay, so the code is running over here. We can see the little hourglass. We can see the asterisks in the upper left-hand corner here. And I'll get into the details of the data, or the code, sorry, the logic behind the script in just a moment. I just want to see this finish off here. Because of the way the data comes in, I actually have to assign a header over here. So we're going to have breakdown, TTM. This is trailing 12 months. This is what happened the last 12 months. Okay, if you look over here, we'll have the same headers, breakdown, trailing 12 months, and then the dates. So here we're looking at annual. We can look at quarterly as well. Let me make sure this script finishes up. I want to interfere with it while it's running. Okay, I think we are good to go here. So it took a few seconds, but it's pretty quick actually, right? And everything comes into this data frame and it's organized in a very neat and orderly fashion. So here's TTM. We have 9/30/2024 to 9/30/2021. Whoops, I think I actually labeled these wrong. Sorry, my mistake. So that's 2023. Okay, let me make a quick change here. Sorry, I am not perfect. I make mistakes sometimes. 2021, 2020. You know what I think happened? Because these headers don't come in, that was entered manually. I think that's what happened there. Let's just check the data real quick. So we have 155,171,000. So this is in millions. So that is 1 billion, right? So that matches that 155,171. And the last record is 70. All these are in thousands. So 70 billion. This is amount 70,830,000. So let me go down here. 70,830,000. And that's exactly what we see there, right? Okay, so we're good. But let me draw your attention to one thing. We have these little drop-down items right here. So this is kind of a parent-child relationship. If we expand these, we can see the details behind that. Okay, so with all of these expanded, I want to capture everything here. So we have 155,171, 60, 492, 64, 804. So 155, 60, 64, 804, 64, then negative 5,968, that is deferred tax. Okay, so negative tax, I think Amazon is famous for this. They make tons of money and they actually have negative tax. So the U.S. government is actually paying them $5 billion in back taxes, even though they made free cash flow of $70 million. So very creative accounting. That's a whole nother topic. It's a whole nother area for discussion. So this is negative 5968. I'm not talking about underreporting taxes or tax fraud or anything like that. This is a totally different topic. Negative 5968000, and that's what we see over here. So the interesting part, aside from the tax thing, sorry to get off on a tangent, I want to go down any rabbit holes. So you have to click on this button to expand it, right? So it rolls up to this level. If you expand it, it rolls out. This is a parent over here, and these are the children. This is the first child. And then this next child at the same level. This would be the next level of children down here. So that's 2 levels down now. And this would be a third, right? So originally, when I was creating this code, I thought, let me click on the button, go to inspect. If I inspect this, we have this window that pops up on the right-hand side. And if I go over here and put this mouse over here, you can see on the left, kind of left middle of the screen, you can see that little button is being highlighted, right? As I go to this XML. So I thought, okay, let me click on this button using the Python code. If we go down here, we'll see the same thing. Let me do it again. Right-click, inspect. It'll take you to, it takes you to here, right? And now the same thing, we'll see the same effect. The button is highlighted when I put the mouse over here. So I was looking for this text, and I thought, okay, if I can get the code to actually click on this text. That's what Selenium does. It clicks on the text just like you would do with the mouse. So Selenium is a very powerful web developing tool, or web screen scraping tool. Sorry, screen scraping, not really developing. That allows you to scroll up and down. You can click on different buttons over here. These are the financials. You have analysis for this company. If I go over here, we can see the analysis behind that. And if I go back, we'll go back to the cash flow statement for Amazon, right? So it's a very dynamic way to interact with the web page, right? And that is all coming from here, Selenium WebDriver, right? That's how I got this thing to work. But the interesting thing was when I tried to click on these buttons, I couldn't get it to work. And I was scratching my head. I was thinking, like, why can I not click on these buttons? And this video almost didn't happen because I couldn't get any of these buttons to expand like this. Every time I click on it, it just wasn't expanding. Then I walked away from my computer, came back less than an hour later. I had to take a little break to figure this out. And then all of a sudden, I saw this expand all button. So when you click on this, it actually expands everything. You don't have to do one by one and loop through a range of button click events. If you just click on this, you can collapse all, click it again, expand all. So if I click this and right click, go to inspect, it takes us to this over here. And let me get over on that. Right, expand all. Let me get back to the inspect element. Okay, so it comes from here. Expand YF. Oh, my eyes are not so good. M6G2L, I think that's what it is. And let me go back here. We're just looking for this button. It's a button click event and expand all. That's what it was. So I wrote this code a few days ago and then stepped away. I forgot that. Okay, so it's actually called expand all. But if you look at it, that's what the button has on it. So we're looking for this text, expand all, right? And we're looking for a button click event. So that's how it works. It's not just magic. There's a lot of logic behind all this stuff. I have a few screen scraping videos I put together, so you can learn a lot about that if you check out those other videos. I'm not going to get into all the screen scraping, but I did want to show you that, right? We look for the button click event, that is right here, and we look for this text expand all. So that's how we get everything to expand, and we go through and create a list and then append everything to the list right here. So there's the name of the list, data.append, and these are rows of data. That's where we're getting the cash flow statement. So everything is imported. Looks great. Okay, let me do a little cleaning because these right here are not given. It's not a 0. It's actually more of a NaN. This is not a number. NaN is the abbreviation for not a number, right? But I want all numbers because I'm going to create a Sankey plot. I want all numbers. So this is going to go ahead and replace anything that has 2 hyphens next to each other with a 0, and these are going to be floats so we can get decimals, right? I don't think there's any decimals here. This is all in billions of dollars. This is 70 billion. But you can see the point. So trailing 12 months now is cleaned up. Instead of the double hyphen that we have over here, we're looking at the tail. Now this is a tail of the data frame because the head had no double hyphens, right? If you look at the first 5 rows, there's no hyphens, there's all numbers in there. That's what you would expect in this cash flow statement. But at the end, repurchase of capital stock, nothing happened, right? Amazon did not repurchase anything, so this is a 0. But I need it not to be a double hyphen, I need it to be an actual 0, because when I try to plot this data, the plot tool doesn't understand a double hyphen, right? That's really nothing. It understands a 0. 0 is a 0. This is nothing, okay? NaN is nothing. 0 is 0. So we have basically the categories of cash flows. So this is how the data structure is defined. We have operating cash flow right here. We have investing cash flow right here. Okay, and then all the constituents are all the children. This would be the parent. So financing cash flow is the parent. All the children are over here. Okay, and this is a dictionary of a list of lists. So anything in a square bracket from here to here is a list. This is a dictionary because you have a key. Okay, these are the values. The dictionary is a key value pair. And you can see it's a dictionary because it has a curly brace down here, ending, and a curly brace over here to open it. So we have an opening, closing, curling braces. This represents a dictionary with the key here and all the values here. And a key can have many values, as you can see, right? And then it's separated by a comma, and then you have the next level here, and then the next level here, and then other cash flows. So anything that doesn't fall into operating, investing, or financing cash flows goes to other cash flows. So let me hit Control-Enter to refresh the category dictionary. Again, it's a list of lists wrapped up in the dictionary, and you can see the hierarchy here. So here's the first parent, here's the second parent, here's the third parent, right there, financing, and here is the fourth parent, other cash flow. Okay, so everything falls into one of 4 buckets. Okay, so these define the rules for the consolidation of all the levels of different cash flows within the cash flow statement. Okay, so each key is a broader category. This is a parent, and all the values are wrapped up for all of these categories, right? Wrapped up nicely in the dictionary. So the script below helps us to map all the details of the cash flow categories into broader, from specific categories into broader categories, or vice versa, right? So here's a broad category right here, operating cash flow. This again shows all the operations, the day-to-day functioning of the business, and let me hit expand all, and you'll have all the details here, right? So here's the broad category, and here's the more specific flow of the cash flow. And I'll show you in a moment why this is important. So we have cash flow, net income, depreciation, amortization, deferred tax. All of this rolls up into operating cash flow. So it's probably, I don't know exactly here, I'm just guessing, it's probably 20 different levels of operating cash flows. For investing, we have slightly less, probably have about 10. Financing, we probably have about 10, give or take. Okay, and then other, this is actually into financing too. And then other would be income tax paid, capital expenditures, free cash flow, so on and so forth. Okay, let's go back here to the code and run this. We were going to get our first Sankey plot. So a Sankey chart is very useful for understanding the flow of data from one point to another. So you can imagine people traveling, flying from one airport to another airport. You can see the flow of that person and all the paths that they took to get from the origin to the destination. It could be the flow of money. That's what we're looking at here. It could be city bikes. I did a video on city bike usage around New York City. And you can see how the city bikes go from one station to another, to another, to another. So you're not tracking people at that point, you're tracking the bike. You can look at people moving. I described that. What's another classic example? Rather than people flying from one airport to another and then onto another, just migration patterns. Maybe people traveling from one state to another state, traveling from one country to another country, not necessarily flying. Maybe you're tracking the vehicle using GPS tracker on the car or something. You could track a person's cell phone. You can see where they move throughout the day. Anything that has a flow pattern is very easily represented in a Sankey plot. So I just hit refresh and we can see how the plot works here. So we have operating cash flows. We have 17 outgoing cash flows. So, okay, made a mistake there earlier. I said 20. This corrected me. This is 17. This is 8 cash flows. And down here for financing, we see 12. And over here is other. We see just 6 for other. So we can see the parent and the children where all the cash flows are going. And what's interesting to me is that some of these go in a circular loop. So they go back to the parent after the parent dispersed the cash flow to all of these constituents over here on the right. Sometimes it actually goes back to the parent. And it looks a little weird, but that's okay because of the hierarchy and the structure of this data and how it's categorized. The loop could occur because of redundancy and the way that the data set is categorized. It could be incorrect or ambiguous mapping. Okay, so this helps us find mistakes. I used to work in financial reconciliation years ago. This is very useful for finding mistakes or some kind of misplaced cash flow. I worked for a few banks. They wouldn't really lose the money, but they could miscategorize it or give it the wrong label or the wrong account number. So once you do that, it's very hard to reconcile the cash and where did it actually go if you made a mistake. Like if it's going to the place you intended it to go to, that's fine. You can trace it easy. If it goes to another place, that's probably incorrect or ambiguous mapping. So this kind of plot is very useful for figuring out if a mistake was made with a categorical code or something like that. And again, data quality issues, right? So incorrect mapping, ambiguous mapping. These are data quality issues, and any kind of Sankey plot will help you identify that. So I think this is a very useful plot, although because of the redundancy here or the looping, we really have to handle this slightly different to get a more meaningful map here from our Sankey. So we have the define function over here, map to source, for source and targets and categories to consolidate. These are all the items, right? All the children items. We want to test if the category is in the target, okay? But this is creating a bit of a loop because of the categorization of data. So I wanted to change this just slightly to have the function perform a little bit different for source and target in categories to consolidate. If category and targets and category equals source, just continue on. I don't want to replot it and remap it, okay? So I changed the logic just a little bit, and you'll see what the effect is down here. Now you have all the parents and all the children, and this is a little bit more intuitive, right? So now you can see there's 16 outgoing cash flows, and you can see all the details here. So if we go over here, you'll see cash flow from continuing operating activities. There's one for 155 million, and that's exactly what we see here, 155. These are all in 155 million. This is in billions, actually, because these are in thousands. This is represented a little bit different. I think there's a mistake with the M over here. See 155M, it's actually 155B, but that's okay. That's just like a little small grammatical mistake. That's fine. So what's the next category here? We have depreciation amortization, 64.8 bill. It's not mil, it's bill, 64.8. That's what we have here. Depreciation amortization, 64.8. Let's look at one more just to illustrate the point. Net income from continuing operations, 60.5 mil. We really know it's bill. 60.5. Okay, it's doing a little rounding. We can get all the details. I don't think that's going to be super useful. I mean, we're just rounding, but for our purposes here, we're proving the point, and I think the lesson has been learned. So that's how you analyze cash flow statements and all the detailed breakdown and plot it in a Sankey plot. These are pretty dynamic, very easy to use, and it's kind of nice too because you can move these things around, right? If you want to create a little more clarity or something that's just slightly ambiguous. These are very dynamic and interactive. I'm trying to grab this last one here. Come on. Not cooperating. Okay, let me get a bigger one. The mouse is just a little bit finicky. So anyways, the point is it's dynamic, interactive, and very meaningful and very useful. So I've got some notes down here. You can go through this at your leisure. It just, again, breaks down the cash flow categories at different levels. Operating cash flows are indicators of profitability, efficiency, sustainability, right? Investing cash flows are for capital allocation of the enterprise, right? Growth prospects, long-term viability of the company. Financial cash flows are for debt management, any kind of financing, shareholder returns, capital structure, so on and so forth, okay? And the code is very dynamic too, so you can just change one small item over here. I can make this is Amazon. I can change this to Microsoft. AMZN, MSFT. Hit Control Enter to refresh. All right, and if I go over here, we're going to pull in all the data from Microsoft. So I always try to make the code dynamic. So you can make one slight little change and analyze cash flows for hundreds or even thousands of companies, right? Quickly and easily. That's the whole point of writing scripts like this. You want to try to make it dynamic, easy to update, easy to maintain, easy to modify, right? And accommodate different people's different needs. So this is importing Microsoft cash flows, and we'll see in a minute. This is doing the cleanup like we saw before, taking care of those NANDs and converting it into actual values, right? So we can go ahead and do the plot. We can't plot anything in Sankey plot that's negative, so we have to convert negatives to absolute values, and we can't plot anything that's not a number, okay? Because the plot just doesn't know what the not a number is. It has to be an actual number. So you can convert double slashes to zeros, and here you see 122, right? For Microsoft, 122, that's operating cash flow. And the last one, 72,662, and if we go here, 72662, okay? And then you refresh everything down below and you'll get all your updates. We can rebuild this hierarchical data structure and replot the data in our Sankey plot. Okay, quick and easy. We see some loops, and that's fine. It's natural. This is normal, but I think this graph is a little bit more intuitive. If these cash flows match each other, we'll just plot from the parent to the child just one way, right? And if we go over here, 122 million for cash flow from continuing operating activities, and we see exactly the same over here, 122, right? So pretty dynamic, pretty flexible, pretty scalable, up and out. I tried to do all the code the same way. So that's pretty much it, guys. Hopefully you learned a thing or two. I will post the video and post this code so you can copy and paste it and run it and change the ticker symbol to be anything you want and import any kind of cash flow and analyze any cash flow from any publicly traded company. Okay, there you go. Thanks for your time today. Enjoy the rest of your day. Goodbye.